to address this issue, and let's start, please.
Thank you very much. It's a pleasure to be here to speak about this topic. It's quite important in clinical laboratories. And I want to start with this slide that summarizes reaction that maybe most of you know that when the so-called highly sensitive or high-sensitive troponin tests were released in the market, clinicians, mainly cardiologists, reacted not so nicely to these new assays. We can quote Robert Jesse, which is an emergency department clinicians, physicians of the United States. And he said that when troponin was a lousy assay, it was a great test, but now it's becoming a great assay, it's getting to be a lousy test. I think that you can start considering, of course, that what are exactly a highly sensitive assay, because there is no question today that we have to adopt them in the clinical practice. I like these reports published about a little bit less than 2 years ago by NICE in UK, that specify the name of the highly sensitive assay, which are evidence-based, supported by evidence-based information. And they say the Roche Lexis TNT and Abbott Acute TNI are recommended as option to early rule out of STEMI in people presenting symptoms of acute coronary syndrome. We will talk later again of this, but in my view, we have to be courageous in mentioning what type of tests are being validated for the use as highly sensitive, not simply look at the commercial names that use different definition. For sure, the bar has been raised, and we need changes in diagnostic rules and algorithms. The first one is maybe the most important, that there is now big evidence that the simple use of a cutoff defined as, for example, 99 percentile limit of the reference population, the distribution of the reference population is not functional for using this test, this highly sensitive test. And we have to rely on serial measurements in order, as we'll see later, to obtain discrimination between acute and chronic pathophysiological mechanism of the marker release. This is supported by biological information. We know that, for example, there is a big individuality in biological behavior of troponin, cardiac troponin, and this means that using reference values of decisional limit is not so useful for interpretation. And this has been confirmed by this recent paper, Australian co-workers, that they showed using the same population and 3 different assays with high sensitive detection, they are able to detect abnormal results in different individuals of the same population. So we have a problem. We cannot use the test simply using this transversal evaluation, but we have to look at the temporal partner or release. And we have to describe this because this is very useful in interpreting the result. But if you have to interpret the release, you have to include, add another decisional criterion, which is related to the entity of decrease or increase of the marker, and main number of scientists call this delta change. That should be defined, and the significance of this change should be defined. And this is not so easy, but it's vital for the interpretation. It's funny to see this survey that FLM Working Group of Cardiac Marker did in 2015. And you can see that the majority of laboratories, European laboratories that were surveyed say, are you using a serial test? Yes, 70%. But in the same rate of laboratories on the question, you are defining the delta change, they say no. So how they interpret serial change is an issue. So we have to define the delta change cutoff that more or less is optimal in discriminating the acute release, significant release of the marker. And this is, for example, a nice study that shows for troponin T, the best compromise is for discriminating significant increase of this marker is 53%. Indeed, the majority of hospitals that use this test use 50% as delta chain. So using this delta chain in addition to the simple concentration of the marker, you can discriminate, as I said before, the troponin, the chronic troponin elevation, which is stable, from the acute troponin elevation, which display this increase or decrease of the marker. But we have a problem because, at least in our setting, but I suspect in many settings around the world, the majority of troponin tests are ordered only once. So it's impossible to get this information of the serial changes. And this is a problem of education for me, in my experience, because we need to explain to clinicians what is the meaning of this delta change and what is the use, and this is added value. So for just an example, this is a report of my laboratory. It's in Italian, but I think that's easy to understand. So we help clinicians in interpreting a variation of the marker by adding to the two values, T0 and admission, and T1, which is 3 hours after this slope called variation just simply calculating automatically the difference in percentage. So we have evidence that applying this approach, we are now able to shorten very much the time for decision and anticipate the treatment of the patient. We move from the traditional 12 hours observation to the 3 hours. So the protocol 0-3 hours is very helping, and this is a very nice paper published last year by the Christian Müller group, and they demonstrate that if you apply the 0-3 hour protocol to the, for example, patient admitted to the emergency department, in comparison with a traditional protocol, we gain more or less 80 minutes in taking decision for ruling out patients. And there are also very nice demonstrations that there is a cost effectiveness of this approach in comparison with the traditional one. This is a paper for UK, and you can see there is an applying this 0-3 hour protocol, there is an incremental cost effectiveness advantage about 3 times. So this was all this information were instrumental to introduce this protocol by the European Society of Cardiology first before in 2011, just suggesting rule out, and after 1 year also suggest the same protocol, similar protocol for ruling in acute myocardial infarction in patients with suspected acute coronary syndrome. We published a quite similar protocol using numbers of troponin T, which is this assay we use in our lab. And you can see that on the basis of the initial troponin value, you can take different decisions and based on retest samples 3 hours later. But what I I'd like to show you is the predictive value of this approach, the 0-3 hour, which are not so perfect, both in the left part. You see negative predictive value is higher than 90%. This means that 10% patients are wrongly classified. And on the right side, you see the positive predictive value is about 85%. So again, not so good, not so close to 100%. And this was confirmed in this paper that tested, validated this 0-3 hour protocol using highly sensitive troponin, and they say practically the same conclusion. So you can use this algorithm to rule in a substantial proportion of patients, but not all patients with infarction could be correctly ruled in, and on the other end, to negative troponin below 99 percentile cannot exclude the presence of acute myocardial infarction. I think that you have to consider the application of the protocol in the specific and in the right setting, which is the setting of emergency departments. The main aim of this colleague is, of course, to approach and use a very consistent strategy that permits rapid but still, of course, safe rollout of acute coronary syndrome suspected patients. And in this survey, emergency department physicians say that they are happy only when the power of exclusion of the test that they use for excluding acute myocardial infarction is higher than 99% of as negative predictive value. So we have to look at this value, not 90 or lower, because otherwise our clinicians, emergency department colleagues are not satisfied. So referring to this goal of higher than 99% negative predictive value, this is a very interesting paper that was published 5 years ago by Rick Bowdy, and you see that this negative predictive value could be reached only if you apply not 99 percentile of the test, but what we call limit of blank. So the ability of the test to detect some very few concentration of troponin. And this has been confirmed by the meta-analysis published in 2015. And you see that at the end, the negative predictive value is more than 99%, which is the goal that physicians are asking for. This has been confirmed several times in the recent years. This is a prospective evaluation of the same approach. You see that using a limit of blank or limit of detection that's a little bit higher of the test, you can reach negative predictive value around 100%. And this has been confirmed in multi-center studies. This is the Troponin study involving 12 different sites around the world. And you see, again, 99%, more than 99% using this approach. And of course, this has been validated also for the other high-sensitivity assays, Troponin I, from Abbott, and you see this is a pooled analysis of 5 international studies, and you see that you reach the 99.5% of negative predictive value using this LOD, limit of detection, cutoff for this specific assays. So you can conclude that if you want to arrive to very close to 100% negative predictive value, you have to apply a different cutoff that correspond more or less to the limit of blank or limit of detection of the high sensitivity assay you are using. So in this way, you can reach a safe rule-out protocol, because less than 1 patient out 100 will be incorrectly classified. But we have a problem on this because, of course, unstable angina patient, which we are not releasing the marker, can be ruled out erroneously by using this protocol. And also, there's a quantitative problem, which is that if you rely on the number of patients which can be ruled out with this approach, the number is very few. So this is a problem. And the other problem is from the laboratory side, but which is central for the application of this approach. The laboratory have to produce very, very accurate troponin values in this very low range of concentrations, because it's clear that even very small analytical variation can influence the decision of clinician taking on only one value. And what we suggest is to add to the classical quality control material additional material with value around the LOB or LOD concentration of the assay in order to monitor the performance of the assay. And just to show you what we are doing in our lab, this is the pool which is used every day to check the alignment of the instrument, and you see that a very low concentration and very narrow acceptability range. And when the pool is showing some alteration, you can recalibrate the system immediately. But the problem was, as I said, that very few people can be ruled out if you apply this protocol. So you need to increase the performance of the algorithms, let me say, fast-track algorithm. And this is the another proposal that use the two measurements at 0 and 1 hour after admission. And that was originally proposed by the APACE study in Switzerland, and then validated in this multi-center study. And you see that in the left part of the slide, the number of patients that could be ruled out safely with a negative predictive value higher than 99% become around 65%. So, which means that you are increasing the number of patients that can be safely ruled out. And from the other end, you see to the right the predictive value of this approach that combine the evaluation of the concentration of the marker together with the absolute delta variation in 1 hour. And you see the predictive value is not so high, 75%. But also this approach has been criticized. People say that there are, the clinical substrate of patients used in the study was inadequate, because there were too few patients presenting early after onset of symptoms. This is not, of course, a randomized clinical trial, but just an observational study, so you have to validate prospectively. And all measurements were done in a central lab, in a core lab, so the performance, the analytical performance of the assay was very well controlled. And finally, last but not least, somebody said they had not applied sex partitioning cutoff. There is a big discussion on this. I don't want, and I have no time to enter on this, but just relating to these studies, I would like to show you this sub-study of the TRAPID. They show that, at least for using this assay, the approach using cutoffs which are differentiated by sex is not useful to increase the utility of the test. Of course, this increase the number of acute myocardial infarction diagnosis in the females, but this does not correspond to the improvement in the outcome of this subject. So, at least using this approach and this test, the partitioning of the reference limits based on the sex is not useful. Do not add anything. Add to this protocol some clinical or electrocardiographic information, and this means that you improve, again, the negative predictive value. This is a very nice example. They reach approximately 100% power to check the follow-up 30 days of the patients when you apply the protocol, or you can add to some clinical score. This is the heart score. It's one of the scores used in cardiology. This protocol, you can increase the power to detect, again, the major adverse cardiac events in the months, 1 month later. The problem, as I said before, is the positive predictive value of this approach, which is substantially low, is not close to the higher 100% that we expect when we have to diagnose acute myocardial infarction. This has been confirmed also for troponin I. You see the values are around from 60 to 70%, quite low for the clinical application. So another approach, option is to try to increase the positive predictive value, is to make the second sample 2 hours later from admission, and not 0.1, but 0.2. And this increase, you see a little bit the positive predictive value. We are reaching 85%, which is still not so perfect, but a little bit higher than before. And this is an option that some scientists, some researchers have proposed. But it's still not, let me say, sufficient, satisfying. I think that you have to consider, as I said several times, the troponin, mainly the highly sensitive test, as a quantitative test. We have not only applied this black and white situation, increase it or not, the values, but you have to consider how much the value is increased. And we know that if the value at admission has a strong increase, you can exclude many of the other not myocardial infarction situations that can justify the increase of the troponin. And this has been validated again in a sub-study of TRAPID. And you see that if you use a cutoff at admission higher than, let me say, 7-8 times the 99 percentile limit, you increase the positive predictive value, and you can go closer to 90%. So you can add to the previous protocol also this right part and consider the initial value. If the initial value is strongly increased, you can increase positive predictive value and support the diagnosis of STEMI in your patients. I would like also to underline the problem of turnaround time from the laboratories, because all these protocols are working possibly well only if the laboratory is able to give the results in let me say 30 minutes or something like that. So it's not only a problem to validate and decide to apply this protocol, but also you need also a laboratory that is working very fast in giving troponin results. You know, for example, that you implement pneumatic tubes together, electronic order entry. You can strongly decrease the turnaround time for troponin results, but in our experience, this is not enough. These are results we obtained 3 years ago when we moved on this organization, pneumatic tube plus electronic order entry. You see the mean of turnaround time was still around 1 hour, which is probably too high in order to apply this very fast-track protocol. So we managed this by reorganizing the lab, implementing a troponin-dedicated path in which every step, including, for example, measurement of hemolysis for interference and the validation, were automatically managed. So in this way, we reduce the turnaround time around 30 minutes, which is which is corresponding to the need for the application, clinical application on the protein. And the interesting thing in this month, when for some problem, organization problem, we come back to the previous organization immediately. The turnaround time in these 2 days increased. The last point that I want to mention is the need that laboratorians are strongly involved in defining guidelines for application of this test in the clinical setting, because otherwise we have some risk in preparing this recommendation. I refer on these recent European Society of Cardiology guidelines in order to show what my concern on what is included. The first one is clear. They are suggesting 3 tests and nothing to do, or nothing to say, sorry. So for the first 2, we all agree that these are very well validated. But what about the third one, which is not in the market, has been published only 1 paper, and then I consider there is no evidence at all to include this in the potential highly sensitive test that can be used. And I think that this is important. If I suspect that 1 laboratorian was involved in these guidelines, this individual could be easily able to mention and to focus on this problem. The other problem for me in these guidelines is that mention independently sensitive, high sensitivity test without any clear explanation of the difference. And in my view, and if you look at the evidence in literature, you can apply this fast-track protocol only with highly sensitive tests, not with sensitive tests. Again, they propose 2 alternatives, 0-3 hours, the classical one, and 0-1 hour, exactly as I mentioned before, putting the same level of evidence, 1B, which is quite high. And in my view, if for 0-3 hours, there is an evidence supporting this evaluation, I don't see evidence to give the same level, a level of evidence to the 0-1 hour. And the other aspect that should be noted, you see that 0-3 hour is just recommended for ruling out, and the 0-1 hour is recommended also for ruling in, which is clearly wrong, because if you look at the results of the 0-1 hour and the positive predictive value is clearly not enough to apply this for deciding the diagnosis of your patient. What I consider maybe the best information from this approach is they are able to discriminate 3 groups. One, of course, is the lower risk group, which can be ruled out easily. One is the high risk group, which is can be diagnosed relatively easy. But the most important thing, they are defining an intermediate group, a gray zone, they call observe. That is really helpful because these are the most complicated patients in the clinical setting, and maybe these can help to improve cost effectiveness of the further approach, as in the study is really very well described. These observed patients need probably more tests, such as stress imaging or angiography, in order to define the clinical situation. I hope this is clear. I think that you have to be a little bit more critical in considering all this information coming in literature, and maybe we have to confirm in our institution what the literature is saying. Thank you very much for your attention.